decision tree classifier. We're going to start by importing NumPy as np import matplotlib dot pyplot as plt, import sklearn as sk. We're going to pull data sets for the iris data set. So from sklearn dot data set import load underscore iris. I'm going to hit F5 just to make sure I don't have any errors, but looks like I do here. The typing happens. All right, so now we're good. And now we need to import a few tools for graph visualization. So we're going to go from sklearn.tree, import export underscore graph viz, V-I-Z, and import graph viz as, we're just going to call it graph viz. Just because it's not a super common package, so sometimes it's helpful to keep the names clear. I'm going to go plt.close all just to keep the code clean as we run. Hit F5, make sure everything's spelled right, everything's loading in, everything's good. So let's start with loading data. We're going to go iris is equal to sk.datasets.load underscore iris. Open and close parentheses, and that should go ahead and load it in and make sure it's there. Looks good. It's in my variable explorer. Not too worried about it. So we're going to go, extract the data we want. And again, this is just to make the coding look a little bit cleaner. Capital X for all of our data is iris data. Then let's get our targets. Just put a comment here. Data. Target. And y underscore names is equal to iris target underscore names. And load all that in. Everything looks like it's moving along just fine. So I'm going to go feature underscore names is equal to iris feature underscore names. That's going to be the names of the features. And this is going to be names of types of flowers. Right, so that's your iris organsia, versicolor, and then features are your petal width, petal length, sepal width, sepal length. Now that I have loaded my data, I need to train the decision tree. So let's go get rid of that extra space. Train the decision tree. And that's going to be tree underscore CLF is equal to sk.tree.decision tree classifier. I'm just going to hit enter so it pulls it all in for me. Max underscore depth is equal to 3. That's just going to keep the tree from training too far, right? It makes it easier for us to visualize what we're building. I'm going to go x underscore petal is equal to X for everything, for all of my rows of column 2 till the end, which is just 2 and 3. Hit F5, everything's still loading in and training all right, so we're good. Now let's go ahead and train the data. So tree underscore CLF dot fit. I'm going to go X underscore petal, comma Y. I had a capital X. I want to stick with the capital X. So this one needs to be a capital X. And there you go. Now I have trained my decision tree model, which happened very quickly. It's really kind of amazing how fast that happens. Now, there are several ways to view the decision trees, right? So first, decision trees are saved in a .dot file. It's kind of a .dot file, kind of an odd terminology, but it's a very common way to save them. There's numbers of viewers online. I like the one that you can find on github.io. So graph viz online. I actually think, not to belabor the point, but it's dreampuff.github.io/graphviz.online. I think that's how they capitalize it. So if you don't want to mess around with viewing the .dot files on your own computer, which can be really weird and kind of sometimes troublesome to do because you have to have different PDF installers and you have to have your system set up right. The online system works well, but then you can also kind of click and drag and change fonts. So it's an option if that's something that you want to do. Now, if I hit F5, I'm training this model, right? But I want to see the model, and I'm going to try to do it to visualize it on my computer because I think that's helpful. So first, I need to set up what this model is going to look like. So I'm going to go export underscore graph viz. And I'm going to open my brackets because that's a command. I'm going to go tree underscore CLF, comma, that's what it's going to export. Out underscore file is equal to iris underscore tree dot dot. I'm going to hit a comma and a new line. I'm going to go features underscore names because it doesn't know what the feature names are, so I have to feed that to it. And I'm going to go equals iris dot feature feature names, and we can go 2 from there to the end. And then I'm going to go comma to class underscore names equal to iris underscore, sorry, iris dot target underscore names, comma, I'm going to go rounded equal to true, just because I like the way that the rounded boxes look. I'm going to go to filled equal to true. And then I'm going to not put a comma, and I'm going to close it out. I'm going to hit F5. Iris is not defined. That's fair. I'll give you that one. Got an unexpected feature name. I think it's got to be feature singular. There we go. Now it's training and executing all the way through. All right, so let's take a look at our folder. And wonderful, we have a dot file. And this is what that is going to look like. And it's just going to be a decision tree, and it's going to piece by piece give you all the nodes, right? So now we've built a decision tree. That's how we store the decision tree. Now we want a way to visualize the decision tree. You can definitely take this file into an online viewer, perfectly legitimate use case, but let's give it a shot in plotting it here in our example, right? So let's go plot decision tree. And we're gonna say load the file back in, which is a little bit confusing. We kicked it out, but now we're gonna load it back in. S equals to graph viz dot source dot from underscore file, and then it's iris underscore tree dot dot. Oh, and that needs to definitely be a string. And let's see if it likes it. All right, I was able to load in an S, so that should hopefully be okay. Let's take a look at S and print S. Success. So we definitely have a tree. I'm going to delete that because I don't need to look at it every time that I render or that I run it. We're going to export the decision tree to a JPEG. We're going to go s.render, and we're going to go iris underscore tree, and that should be the file that we're rendering. We need format is equal to JPEG. JPEG seems to be the most easy one that most computers can handle. And view, let's go true. That should just open it up. Perfect. And now we have our plot showing up for our decision tree. So overall, seems to work pretty well. All right, so now let's go ahead and take a look at how we can actually make predictions from our decision tree. So let's say we have size is equal. I have to put it in a nested list here, which is 7, 2.5. And that's what I'm going to say that, hey, I have created a leaf. I have found a flower of this size. And let's see what the actual prediction about this flower is. So I am going to print tree underscore CLF dot predict. Underscore PROBA, so the probability of size. And let's see what I get. So we're going to put true to false here. There we go. And so it's going to predict it as class 3, which is far out here and to the right. And so to visualize that, let's pull in the plotting that we've been using for the decision trees up to this point. And we don't need to recreate this. Sorry, not decision trees, but for the iris data set. So there's an iris data set. And now if I were to say plot this, let's not do it here. Let's just come down here and go plt.scatter. And let's go size of 0, 0 against size of 0, 1. And let's go S equals 300 and marker is equal to a asterisk, which should give us a star. And that gives us a class way out here, right? So if I move my class way out there, my decision tree is giving me a prediction that this is a Virginsia with probability of 1 or 100%. I can then do some cool things. Let's try a 5 by 1.5, a 5 by 1.5. That should give me 1. A little hard to see here, but it's right there. Here, let's do see if I can get my arrow to show my red star to show up on top. There we go. So now I've got a red star on top, and I've got a 33% chance that it's a versicolor and a 67% chance that it's a Virginsia, right? Which makes sense. Let's move it down a little bit to the left so I can have 4 by 1.5. And I should, depending on how my decision tree trained, yep, I should, now I've got a 97.8% chance that it's a versicolor and a 2% chance that it's a Virginsia. So decision trees are a very powerful way to do classification, relatively easy to use. They're explainable, which is nice because you can go through and image and predict kind of your flow through the path, right? And again, these colors don't match with the colors that we had, but that's okay.